Hello, am I audible?
Yes, sir.
Okay. Good evening, everyone. So I think I'm seeing you after a long time, I guess. I was not well in between, so I was not conducting the session anyway. So yeah, so I think it's a long break for me, at least 2 to 3 weeks. I think I was not there. But okay, that's. I hope all things are clear until week 10. We have only, I think, next week we have exam, right? So I think this term is itself is very shorter term, right? So I just wanted to start with the first thing that how we are going to map out our sessions, right? So uh, can I get to know that what's the deadline for week 11 and 12?
Deadline has crossed for week 11.
Is it closed? Okay.
Yes, sir.
When it
It
was
was
closed?
yesterday.
Yesterday.
Yes, sir.
Yes, sir. Yesterday.
Okay. So but still we'll conduct week 11 session today. If you have any doubts and everything, we can just sort it out today's session. Fine. Maybe week 12. Shall we have? And what is the deadline for week 12? Sunday,
Sir, I think it's 18th.
18th December. So 18th will be Wednesday, right? And then you will have exam on Sunday, right? So 22nd of September, December. Okay. Is that correct? Like you have exam on 22nd of December, right?
Yes,
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 sir.
sir.
So 18th is Wednesday. Okay, fine. It is. I'm not sure. It's very tough times, right? So yeah. Okay. So I think week 11 is deadline is over. So do you want me to go through week 11? If you have any issues, I think I can cover week 11 today, and maybe we can have one session on Sunday, and maybe if you want, we can have two sessions on week 12, which is on Sunday maybe, and or Saturday and Sunday, both days, and then we can have the revision session on the Thursday and Friday. Will that be fine?
Yes, sir.
So shall we have? Okay, I'll just mark into the calendar. So possibly we can have session on Saturday. Saturday already you have the TA session, right? From 7 to 9 p.m. And Sunday you have solve with us for. Uh, I think we can make it open session. So when do you want the session to happen for week 12? We'll have two sessions for week 12 before Wednesday, right? So we can have two sessions. Which days will you prefer? Monday or Saturday? Or anything? Monday, Tuesday, you have the options like Saturday, Monday, Tuesday. Sunday session will be there definitely. You can have one of the sessions, and then Thursday and Friday, you will have the revision sessions for MLF entire like week 1 to 12 or whatever. What is the preferable timing for all of you?
So from my side, Saturday, sir, so that we can finish early, but please check with others.
Yeah, Saturday, what timing? Timing. So please. Uh, so 7 to 9, you have a TA session, right? So is it okay 5 to 7 or something? One session from 5 to 7 on Saturday and 5 to 7 on Sunday.
Sir, 5 to 7 is fine.
Saturday, right? So
Yes,
we
sir.
can have one session on Saturday for week 12 and one session on Sunday for week 12. And then next Thursday and Friday, we'll have the revision session. So in that, we'll cover the mock session question also, right? Okay, fine. I hope, okay, then I will make the changes in the calendar accordingly, and we can just start. Okay, fine. So
We'll be
today,
having a mock. We'll be having a mock for end term.
yes, you will have. We will have that mock session also, right? So actually, I was not there for a few weeks, so I am just like little bit out of touch of what's this happening in MLF. So I saw a couple of posts on the discourse that you guys have some issues with the quiz 2 marks. I don't know. Is it sorted?
No, sir.
It's not sorted. What is the issue? Can you just tell me what is the issue? Uh, Anybody? Okay. Maybe I'll check. Today I'm going to check all the things. So maybe I'll check all the discourse post and everything. Somebody was saying about, I think there is a discrepancy in one of the options, I guess. I think two, or there are three options correctly given, I guess. And out of which only two are correct or something like that.
Yeah,
Some issue is
yes,
there. I haven't gone through like properly, but I think there was some issue there. Okay, I'll check, and if needed, we'll provide you the clarification on the same. Okay, so we'll send out the detailed notification regarding this. Okay, I think that is sorted, but I have to check once. I haven't seen all those posts, so I have to check once again. Okay, what do you want today to happen in today's session? Week 11, shall we discuss certain problem on probabilities, random variable, multiple random variables?
Sir, please
Uh,
give problems in which the entire topics can be covered.
So shall we solve some problems in the grade assignment itself? Already grade assignment deadline is over, right? So
Yes,
do
yes,
you?
yes,
So that will be fine. All the grade
yes, yes,
assignment questions.
yes, yes, sir. That will be great.
Okay, then we'll discuss the grade assignment problem. Any issue in the concept also, right? You can just tell me right away, not an issue. Okay, so we can, because I think all of you know all these things already in stats 1 and stats 2, but it's like you have one term of gap or something like that, right? So maybe you guys have forgotten the concept. So any issues anywhere, you can just raise your hands, you can just speak in between, not an issue with that. Okay. Okay, so this is the first question. I think you're sure, right? Deadline is over because I haven't checked. So this is the previous terms portal. So okay, so the question one is the number of hours Messi spends each day practicing in ground is modeled by the continuous random variable x with probability density function given by this. So you know, right? So for discrete random variables, we have what? Probability mass function, right? So there are two things, right? So we have one as a discrete random variable and another as the continuous random variable, right? So if you have a discrete random variable, we will have the PMF, or what we call it as probability mass function, right? And what are the properties of probability mass function? So suppose x is a random variable which will have some range of right. So any range will be there. So in a discrete random variable, you have discrete values. It will be taken as discrete values as a range, right? So first of all, let us try to understand what are these things, right? Let's say you have an experiment. So I'll take a simple experiment first. So you have one experiment of tossing a coin, right? Tossing a coin. So when you toss a coin, what are the outcomes? What are the basic outcomes? You will have two basic outcomes, right? One is head and another one is called as a tail, right? So this is what experiment is there. So in probability, what you do is you have a sample space. So what is the sample space? Can you tell me what is the sample space?
Set of
Sample
all the
space.
outcomes.
Yeah, so sample space is nothing but a set, right? It is a set of all possible basic outcomes, right? So sample space is denoted by S or uh, omega, right? And it is what? It is a set. Set is denoted by what? Two curly brackets, right? So in this case, if I have an experiment of tossing a coin, what are the possible basic outcomes are there? Head and tail, right? So that is my sample space. These are the only two outcomes which are possible, right? Suppose you have taken another experiment of rolling rolling 2 dice, right? So what is the sample space corresponding to that? If I roll 2 dice, or maybe rolling 2 coin, or maybe I'll say tossing 2 coins, right? So let's say tossing 2 coins. So what is the sample space here?
H, 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 T, 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 and TH.
H, T, TH, and TT. Right?
TT.
Right. Okay. So let's say these are the this is the sample space. Now let us say what is the random variable then? So suppose I define a random variable x such that it represents number of heads in tossing 2 coins. Okay. So if I represent, so we have to define some random variable, right? So now this is a random variable x which represents number of heads. So in this sample space, how many, okay, let us say x will be number of heads, right? So how many heads are there in, if this is the event? So these 4 are basic outcomes, right? These 4 basic outcomes we can call it as events. So for the first outcome, how many number of heads are there? 2, right? Here
1 and 0.
1, here 1, and here it is 0. So if x is a random variable here, what are the values taken by it? What is the range of, that is the range of random variable, which is what? 0, 1, and 2, right? And okay, so suppose these are the fair coins. What do you mean by fair coin?
Unbiased.
Yeah, what does that mean? That means that equally likely outcome, right? That means the probability of occurring that event, right? So it is like equally likely. So for example, in sample space, if I tossed one coin, we have 2 outcomes, which is head and tail. In that case, when I say equally likely outcomes, so that in that case, what is the probability associated with the head, which is 1/2, right? Because there are 2 outcomes possible, and out of which this is one of the event, right? So getting head is one of the events. So 1/2 is for head and 1/2 for the tail. So in that case, this is equal likely outcome. If I toss 2 coins, what are the probabilities associated with all these events? So with HH, what is the probability?
1/4.
1/4, right? So each one of them will have the probability as 1/4. But the value taken by the random variable are what? 0, 1, and 2. So what is the probability that x will take value as 0? What do you mean by x equals to 0?
No heads.
No heads, right? So which is the favorable outcome here in the sample space? TT, right? Right? So x, when I say x equal to 0, what is the probability of x equals to 0? 1/4, right? Okay, so when I say x equal to 1, what does that mean?
1 head.
1 head, right? So how many possible outcomes are there? So this is one of the outcomes, because head on the first coin and tail on the second coin, and another is tail on the first coin and head on the second coin. But in both these outcomes, what is common here? It is having only 1 head, right? So in that case, what is the probability of getting 1 head? 1/4 plus 1/4, right? Which is 1/2. Is that correct? And what is the probability that x equals to 2? What does that mean by x equal to 2? That means 2 heads, getting 2 heads, right? In that case also, we have only one possible outcome, which is head-head, and the probability associated with this is 1/4. So the probability mass function can be written as like this. It can be tabulated as like this: x equal to 0, 1, and 2, and probability that x equals to small x. Small x means the values taken by the random variable. So it can take 0, it can take 1, it can take 2, and the probabilities associated with that is 1/4, 1/2, and 1/4. Okay, so this is called as, this table is called as probability mass function. This can also be written as like this. So it can be written as like this. I hope all of you know all these things already. So, but I'm just writing out, right? So when x equal to 0, 1/2 when x equals to 1, and 1/4 when x equals to 2, right? See, these both are the representation of what? Probability mass function. What are the properties of probability mass function? Equal to 0. Another is what? Summation of all the probabilities across the range of x, right? So is equal to how much?
1.
1.
1, right? So it's 1/4 plus 1/2 plus 1/4. You can see it should be equal to 1. These are the properties of probability mass function. There is one more term which is called as the CDF. What is CDF? CDF is called as cumulative distribution function, right? So what does that mean?
So it means basically that from a point in the range of the starting point of the range, like till the point till where we have to find the CDF, we cumulative, what is the probability?
Yeah, so so it is denoted by what? Let's say fz of z, right? So what is the formula, or what is the equation? Probability that
It's less than or equal to zero.
z is less than or equal to z, right? So
Yes.
that means we are just going to add all the probabilities over the range of that random variable, right? That's the basic idea about it, right? So in this
Yes.
case, what will be the values taken by this fz? Let's say here it will take value as 1/4 from where to where?
X equal to 0.
To zero.
Okay, x equal to 0. Then it will
3
be
by 4.
at x equal to 1, it will be
3
3
by
by
4.
4, and x equal to 2, it will be
1.
1.
1, right? So, and if I try to draw the graph, what kind of graph it will be? A step function, right? Is that correct?
Yes,
If I
sir.
it will look like something like this. I think x equal to 0, let's say you have probability 1/4, then it will, so here on x-axis it is x, so let's say values taken by random variable, so it's 0, 1, and 2. At 1 it will jump, right? It will jump to 3/4, right? And then again it will constant over L2, and then it will jump to 1, right? Okay, and it will be it will remain at 1, right? So okay, this is the CDF. So I think all of you know all these things. These are very basic things. There is one more thing is which is related to continuous random variable. What it is called? Very like analogous to PMF. What is it there? PDF,
PDF.
right? Yeah. And what is the full form of it? It's probability
Density function.
density function, right? Okay. So it will also have the similar properties as that of PMF, right? What are the similar properties of PDF? So all the probabilities. What is the difference between discrete random variable and continuous random variable? Like basic difference. You can think about in terms of range. what is the basic difference between the range of this both the random variables?
So discrete random variables take a definite value, whereas continuous are always considered in a particular range, right?
Interval, right? So
Interval, yeah.
yeah, so here in discrete random variables, it will take the countable values, right? And in continuous, we will have the measurable ones, right? Measurable and countable means you in case of discrete random variables, there is no interval between the values. For example, if you take if the random variable is taking value as x equal to 0, after that it can take 1, it can take 2, or it can take 0.5 also, or in between values, but it will jump from that 0 to 0.5 or 0 to 1, right? It will not take all the values in between that interval. Between, let's say, 0 to 1 interval, it will not take all the values. But in case of continuous random variable, it will take all the values in that interval, right? So the question which we are having here, this is of what? A continuous random variable, and you can see this range, right? So what is the range here? X is taking value between 1 and 6. So when I say it is taking value between 1 and 6, is it taking values 1, 2, 3, 4, 5, 6, or all the values between 1 and 6, like 1.111, 1.112, like that, up to 6?
So all the
All
values
the
from 1 to 6.
All the values, right? Okay. So now we'll try to solve this problem. So number of hours. So number of hours is like kind of measurable one, right? So the number of hours Messi spends each day practicing on the ground is modeled by this continuous random variable. And okay, what is one more property which is important is what? Uh, the sum, when I say in probability in discrete random variable, when I say sum of the all the property all the probabilities, it should be equal to 1. In continuous random variable, what it will be? The integration, right? Integration over the range of that values should be equal to 1, right? Okay, so f of x is equals to, what is it, a into x minus 1 into 6 minus x between when x is between 1 to 6 and it is 0 otherwise. Okay, so what we have to find out here, first of all, we need to find the probability that Messi will practice between 2 to 5 hours. What does that mean? It means probability that x is between 2 to 5, right? This is the probability we need to find out. But before finding out the property probability, what is missing here, or what is unknown to us here?
value of A.
The value of A, right? So now how to find the value of A? We know that integration from 0 to infinity over this, it should be equal to how much?
1.
1.
Right? Yeah, so I think it's from minus infinity, right? So fine. But our, what does actually, it should be like between minus infinity to 1, it is equal to 0, right? So over the range, actually we have to integrate here. So 1 to 6, and what is it? A into x minus 1 and 6 minus x dx. So what is the integration? So A is constant, right? So I can take A outside. Okay, can I expand it here? What is the expansion? It is 6x minus x square minus 6 plus x, right? To dx. So here it's 1, integration from 1 to 6. Here also it is 1 to 6. It is equal to now minus x square plus 7x
Minus 6.
minus 6 and dx. So what is the integration? And it should be equal to how much?
1.
Right? Yeah. So the right hand side, the left hand side should be equal to 1. So I'll say that A is constant outside. What is the integration of minus x square?
Minus
Minus
x cubed
X
by
cube
3.
by 3. What is the integration of 7x?
7x square
7x square by 2 and minus 6x,
x.
right? And from where to where?
1 to 6.
1 to 6. So I'll just put like or substitute the upper limit here. So upper limit is 6 and lower limit is 1. So upper limit, if I substitute here, what it will be? Minus 6 cube by 3 plus 7 into 6 square by 2 minus 6 into 6. And again, from that, we have to subtract what? The lower limit, right? So minus 1 cube by 3 plus 7 into 1 square by 2 minus 6 into 1. So let us see the value. And the left hand side is equal to 1. Then a is outside as it is. Inside, what is 6 cube? So 6 cube, I can write it as 6 into 6 square, right? So minus 6 into 6 square. So 6 square is 36 and divided by 3. So 3 into 2. So this will become 72, right? That's correct, right?
Yes, sir.
Minus 72 plus here, if I 6 square, I can just like split as 6 into 6. So it is 3. So here it is, I think 42 into 3. How much it is? 42 into 3. And 126, right? Is 126 minus 36 minus minus 1 by 3, because minus 1 cube is how much? Minus 1 plus 7 by 2 minus 6. Okay. So if I just, what is the value here? 172 plus, huh? How much?
18. 18.
18.
Yeah, I think so. 18.
6 and 2. So 70 and 30 is 100. 108 and 126 minus 100 is 18. Yeah, right. So it's plus 18 minus how much it is here. So by 7 minus 12, it is minus 5 by 2 minus, so minus 1 by 3 minus 5 by 2. So this is 2 minus 15, right? Minus 2 minus 15. Minus 17 by 6. That will become plus, right? Is this correct?
Yes, sir.
And here, this will become 108 plus 17. So this is 15, 125, right? So 125 by 6. So into 125 by 6 equal to 1, right? So I'll just take it to right hand side. Now what is the value of a then?
6 by
6
20.
by
125.
125. So when I have this a, the value of a as 6 by 125, then this PDF, right? Because it's a continuous random variable, it is a PDF. This PDF will become what? Valid PDF over the range 1 to 6. I hope all of you are aware of all these things. If you have any doubts, you can just ask me there itself. So f of x is now what? The PDF is now 6 by 125 into x minus 1 into 6 minus x, right? 6 minus x over the range 1 to 6 and 0 otherwise. Okay, now I got the value of a. What I need to find out now? Probability that x is between 1 to
5.
5, or sorry, 2 to 5. So what I have to do now, if I wanted to find this probability, I have to integrate this PDF, right? This PDF, or from where to where? So this is my lower limit now, right? And this upper limit. So between 2 to 5. So I have to integrate between 2 to 5, which is 6 by 125 x minus 1 and 6 minus x dx. Is okay?
Yes, sir.
Everybody, I'm not going too fast, right?
No, sir.
Okay, fine. So because see, these are like very basic concept in week 11. Week 12, we are going to build on all these concepts into different. So there will be very very complex concepts will be there in the next week. Right? So it's Gaussian random variables, then multiple normal random variables. You just have to understand the single random variable first, and then we can discuss about multiple random variables. Okay, so yeah, so here we need to find out the probabilities. So I can just integrate over the range 2 to 5. What is another way, any other way, to find out this probability? Do you know the way of CDF? Okay, maybe I'll just solve that way also, fine. First
0
place,
to 5 to 0 to minus 0 to 2.
yeah. So basically, let us say if I wanted to find probability that A x is between A to B, I can find it by f of B minus f of A, right? This
Yes, sir.
this
Yes,
property
sir.
and f of B is what? It's like CDF of until that value B, right? So we have to find out the CDF from the PDF, and then we have to use this. But I'll show you that also. First place we'll discuss this way. We can just integrate. Both are the fine ways. Okay, so you can just get the same answer. I will show you that way also, so that you will not stuck anywhere else in between. So right. So yeah. First place. Okay. What should I have to do? So 6 by 125 is it's constant, so I can take it outside of this integral, and inside if I just expand it again once again, so this will be 6x, right? Sorry, yeah, 6x minus x square plus, sorry, minus 6 and plus x, right? Again the same expansion here. So here I can have 6 by 125, so it will be minus x square plus 7x minus 6, right? Into dx and integral over 2 to 5. So here 6 by 125 as it is. Here it will be minus x cube by 3 plus 7x square by 2 minus 6x. This is the integral, and we have to integrate from 2 to 5. So firstly I have to substitute the upper limit, and then I have to subtract it from the lower limit.
So we will solve it, sir, because it's the same as what you said before.
What happened?
So we can solve this because it's exactly the same as what you had explained.
Yeah, okay, yeah. I'll just so somebody needs the final answer, right? I don't know if you guys you didn't get the answers, right? Or you got the answers also. I don't know. It's like the answers are uploaded. Okay, fine. I'll just do it quickly then, right? So 5 cube is how much? 125, right? Minus 125 by 3 plus 7 into 25 by 2, which is 175, right? Minus 6 into 5, 30, minus 2 cube is 8 by 3 plus 4 into 7, 28 by 2, so which is 14 minus 12. Okay. Now you can solve it from here, right?
Yes, sir.
Okay. So I'll just keep it here itself. Okay. There is one other way, which is the CDF. So how to find a CDF of this? So FZ of, let's say, Z here, or it can, what is it? Probability that X is less than or less than or equal to X, right? So in that case, what is, I have to, so what is the range of this random variable? 1 to 6, right? Between 1 to 6. So here I have to integrate it from 1 to x, right? To find out the CDF. All of you know how to find out the CDF?
Yes, sir.
So it is 6 by 125 into the same equation again, right? So I'll just use the expanded version of it, and that is minus x square plus 7x minus 6 dx. So what it will be then? 6 by 125 outside. What is it? Minus x cube by 3 plus 7x square by 2 minus 6x, and I have to integrate from 1 to x. So what is the CDF? 6 by 125 here, minus x cube by 3 plus 7x square by 2 minus 6x minus 1 by 3. So okay, I will not minus of minus 1 by 3 plus 7 by 2 minus 6. So here this will be 6 by 125 minus of x cube by 3 plus 7x square by 2 minus 6x, and what will happen here inside? So here it is minus 1 by 3 plus 7 by 2 minus 6. So 7 minus 12 is how much? Minus 5 by 2, and this is 2 plus 15. So minus 17 by 6, which is plus 17 by 6. This fine? Is this okay?
Yes, sir.
So this is what? This is the CDF of my, right? So let's say this is the CDF. Now I need to find the probability that x is between 2 to 5. So what I said to you, let's say what generally what should be the probabilities? Probability of, let's say, A and B are the two values. I wanted to find in between that the probability between that two values. So it will be generally f of B minus f of A, right? So that means here it should be f of 5 minus f of 2. So what should I have to do here? I have to just replace these values here. So 6 by 125 and here it will be minus 5 cube by 3, which is 125 by 3, right? Minus 125 by 3 plus 7 into 25. So how much it is? 7 minus 30 plus 17 by 6. Again, it will get cancelled when I use 2 there, right? That's fine, right? I hope it is okay. You understand that part. So 2 cube by 8, so it's minus 8 by 3 plus 7 into 2, which is 14, and minus 12, right? So this plus 17 by 6, if I use here plus 17 by 6 and then I subtract it from f of 2, then again we'll have that 17 by 6, right? So it will get cancelled anyway. That's why I didn't use it here. So if you can just see the values which I found out here, you can just compare it with the previous thing. See, minus 125 by 3, 175 by 2, minus 30, and from that minus 8 by 3, 14, and 12. So if you see, these are the same values. Fine? This is fine?
Yes, sir.
All of you are okay with that part? Okay. Okay. So that is your first question's answer. You can check the final answer by using these values, right? Okay.
Sir?
So how will you solve? What is the second question now?
Hello, sir.
Yeah.
Sir, please upload the PAs and GA solutions.
Yes, yes. I'll ask the team
Okay.
to upload it today.
It has been uploaded till
Week 8.
week 7 and 8. Yes, sir.
Okay, yeah. 9, 10, and 11 are yet to upload it, right? So I'll ask them to upload it. By today itself,
Okay, sir.
we'll
Thank
ask.
you, sir.
Yeah. Okay. How to solve the question number 2 now? So,
It's the same, sir. Same method.
so you can solve it right now. What do you have to find out first here in this question?
A, sir.
The value of A, and how will you find it out? So here you have two ranges, right? So maybe I'll just show you how to find the value of A, and you can then solve the probabilities. I think probabilities you can solve easily. Can you just tell me what is f of x? So it is ax, here a into 4 minus x. So ax is between 0 to 2, 0 to 2, and a into 4 minus x is between 2 to 4, right? 2 to 4, and it is 0 otherwise. Okay, so this is my PDF because it's a continuous random variable. Now, how to find the value of A? So, according to the properties of PDF, I know that over the range of values, if I integrate all the probabilities, what will happen? It should be equal to 1, right? So, integration between 0 to 2 fx of x plus between 2 to 4 fx of x dx, fx of x dx plus, and okay, 4 to infinity it is equal to 0, so because it's 0 otherwise, right? So between 0 infinity to, okay, maybe I'll use all the things. So minus infinity to 0 fx of x dx plus 4 to infinity fx of x dx. If I integrate all over this range, that should be equal to 1. I know between minus because the function exists between 0 to 2 and 2 to 4, right? And otherwise it takes value 0. So integration of 0, right, over any range, it's equal to 0, right? So this part is 0 and this part is 0. Now I have to integrate between 0 to 2 and 2 to 4. So between 0 to 2, what is the value of function? It is ax. So ax dx plus integration from 2 to 4, it is a into 4 minus x dx, and that should be equal to 1. So what is the integration here? Ax dx, a
Ax square by 2.
x square by 2, and so the limits will be 0 to 2 plus integration of this a into 4 minus x. What is it? So if I can take a as common, so here it is
4x
4x minus
x square by 2.
x square by 2, and what are the limits? 2
2 to
to 4,
4.
and that should be equal to 1.
1.
Okay, so a into 2 square by 2, how much it is? 2, right? So it's basically 4 by 2, which is 2, and 2 minus 0. So lower, if I put 2 square here, so upper limit here, it's 4 by 2, and if I put 0, which is the lower limit, so it is 0, plus a into, if I put 4, what is the value? So 4 into 4, 16, minus 16 by 2, which is 8, minus lower limit. Lower limit is 4 into 2 as 8, minus 2 square by 2 is how much? 2. And that should be equal to 1, right? So 2 minus 0 is 2. So here I will have 2a plus a into 16 minus 8 is 8, minus 8 minus 2. So here this is 8. 8 minus 2 is 6. So 8 minus 6 equal to 1. Again it is 2a, right? So 2a plus 8 minus 6 is 2. So it's 2a equal to 1, which is 4a equal to 1. Therefore a equal to 1 by 4. Now your PDF will become PDF will become as how much A is 1 by 4. So it is, I think it was AX, right? It was AX. So x by 4 between 0, when x is between 0 to 2, and 1 by 4 into 4 minus x when x is between 2 to 4, right? A into 4 minus x, and 0 otherwise. Now, how will you find out the probabilities? We have to find out the probability between x. You will take the values. You can find out the CDF also, or you can directly integrate between 1 to 3. But is it the straightforward integration here?
No, one to
So
two
how will
and
you do
then
that?
2 to
Yeah,
1 to 2 and then 2 to 3.
yeah. Why we have to do that?
The piecewise function.
Yes, 2 to 3, and it will be what then? 1 to 2 x by 4, right? Because 1 to 2 is in this range, so it's x by 4 dx, right? And plus integration of 2 to 3, what is it? 4 minus x by 4, right? Or I can just say that 1 by 4 common, 4 minus x dx. So the, sorry, where it is? Yeah. So here 1 by 4 common, it is x square by 2 between 1 to 2 plus 1 by 4, 4x minus x square by 2 from 2 to 3. So 1 by 4, x square by 2 is, so upper limit is 2 minus lower limit is 1 by 2 plus 1 by 4 here. Upper limit again here is 4 into 3 is 12. 12 minus 9 by 2, right? Minus 8 minus 2 square by 2 is 2. So this will become 2 to the 4 minus 1 is, which is 3 by 2, right? So 1 by 4 into 3 by 2 plus 1 by 4 inside 24 minus 99 is how much? 15 by 2 minus 6. So this is 3 by 8 plus 1 by 4 into how much it is? 3 by 2, right? 3 by 8 plus 3 by 8. 6 by 8, and 6 by 8 is nothing but 3 by 4, which is 0.75, right? Just check your my calculations also. Okay, so I think that's the correct one. Yeah, this is in between 0.7 to 0.8, and our answer is 0.75. I hope it is clear to all of you. If you have any doubts, right, whenever you, if you are having doubts finding out the limits, you can just tell me.
Sir,
Yeah, yeah.
sir, I have a small
Yeah,
doubt in
tell me.
lecture 11.3.
Uh,
Sir, how to find expectation in the
here, question number 3, right?
no, sir, lecture number 3, 11.3.
Expectation.
Yes, sir.
So our question number 3 is regarding expectation. Shall I solve that, and then that will be fine, right? No?
Sir, I understand expectation, but sir, using one other formula to find expectation. I
Okay.
can give you time stamp if you want.
You can tell me now what is the formula there. You can just tell me. Okay.
Just a second, sir.
Yeah, just
Sir,
check.
expectation formula it is a conditional expectation into probability of A.
Hi, you can tell me. Okay, maybe I have the PDFs here. 11.3, right?
Yes, sir.
Here these are the PDFs. So maybe PPTs. So you can just tell me which one you are having issues. What is the generally you know, right? What is the expectation formula?
Yes, sir. Generally, I know
Huh.
it is a conditional into probability of A plus conditional into complement of A. This formula, sir.
It's not in 11.3. Expectation is not there. Expectation where is here. This one, right? This is the formula. It's correct one, right? X into fx of x. Where you are facing issue here?
No, sir. After this, 11.3.
This one? Variance formula. No, this is
No,
variance.
sir. I understand variance.
Okay, let me check your understanding first. So this is the PDF for you, right? Are you able to see this question number 3?
Yes, sir.
So this is PDF of x, right? Okay. Now if you wanted to find out what is the expectation of x here, how will you do that here in this question? So I'll write it for you and you can tell me the steps. We can so that we can understand if you have any issues or not. Okay. Let us see. X. So it's not like you need not to do everything whatever there in the lectures. Okay, if you have any other formula with you and if you are able to solve it through that, it's fine, right? Because the answer should be you should get the same answers. I'm not sure what are you talking about, but let us say this is the PDF for you. If I wanted to find the expectation of x, how will you do that? Now, first place, is it a PDF or PMF?
Sir, it is a PDF.
PDF, right? Yeah, that means it's a continuous random variable. Now I
Yes.
wanted to find out the expectation of x here. What will you do here?
First is integration of x into x range 0 to 1 or
Limit
something
is
x,
limit is 0 to 1.
x square dx.
X into fx dx. So f of x here is x,
X.
right?
Yeah, so
So that
x
is x
square
square dx, right?
plus
Uh,
sir 2x minus x square
1 to
dx.
2 into x into 2 minus x dx, right?
It is 2x minus x square
That
dx.
is correct only. No issues there.
So sir, I'm able to find, sir, but sir, something tell us one more about formula. So I'm confused.
No, this is okay. I think you are talking about that convolution formula. That is not for expectation, right? I think. But okay, so you can just tell me the timestamp. I can just check it later. But
Yes.
this is fine. This is so if you are able to solve it through this, right? That should be
Yes, sir.
your answer. You can just see that it's like 1/3 plus how much it is? So 4 minus 4 minus 2 minus 1, right?
Yes, sir.
So this is 1/3 plus
That should be 2x square by 2, right, sir?
2. Right. Yeah. So 2. Sorry. I think it is x square, right? Sorry. This is 2 into x. So that means it's x square minus x cube by 3, right? Yeah.
Yes.
So the upper limit will be 2 to the 2 square, which is 4 minus 8/3 minus 1 minus 1/3. Right. So 12 minus 8 is 4/3 minus 3 minus 1, which is 2/3. Yeah. 1/3 plus 2/3. Is that correct?
Yes, sir.
Should be equal to 1. This is correct. This is the correct answer. See, the answer is 1, right? So that's the correct answer. Okay, if you understand this formula, that's enough. If
Sir,
you have
sir,
any,
I understand, but sir, those formula is very simple, but I have only small doubt.
no,
So
you can tell me. You can just you can maybe you can take a screenshot of the that particular lecture where it is there, and you can just share the screen. Okay, you just go through the lecture once and tell me during the session itself. We can just find it out. Fine.
Okay, sir.
Yeah. So till that time, I just go through some more questions. Okay. Yeah.
Okay, thank you, sir.
Yeah. So the question number 4 is the distribution of the length of a cricket bat is uniform between 80 centimeter and 100 centimeter. There is no cricket bat outside this range. The mean and variance of the lengths of the cricket bat is A and B. Calculate A plus B. So uh, the distribution of the lengths of a cricket bat is uniform. So let's say if you have the random variable x, which denotes or which represents the length of a cricket bat, what kind of random variable is this? Is this a discrete random variable or a continuous random variable?
Continuous.
It's a continuous random variable. So suppose my x is given here. So x is a continuous random variable, which is what? Uniform. And what is the range of that? Uniform between
80 and 100.
80 and 100, right? So yeah, 80 and 100. It's a continuous uniform random variable. Now there is no cricket bat outside this range, so I can understand that the values outside it is not valid. So what is the PDF of this random variable?
1 by 20.
So which is 1 upon b minus a. So let's say if this is between a and b, is 1 upon 100 minus 80, which is 1 by 20, right? So this is the PDF. Now what is asked me or what has told to me is that the mean and the variance of the length of the cricket bat is a and b. So expectation of x is given to me as a and variance of x is given to me as b. So do you know that what is the expectation of a uniform random variable? A plus b by 2, right?
Yes.
Or in this case, a is
80 plus 100 by.
yeah.
80
So it is
plus
80 plus 100 by 2, it should be equal to a, and that is nothing but 90, right? So a is 90. And what is the variance of a uniform random variable?
b minus a square by
Square
12.
by 2. 12, right? Yeah. So 100 minus 80 square by 12 is equal to b. So 100 minus 80 is 20. 20 square is 400, right?
400.
So 400 by 12 is b, and b is nothing but the 3 and or 3 point something. Yeah, 33.33 something, right? Or 34 if I round it also.
Yes.
Right? So this is the value of a and this is the value of b, and we have to the question is calculate a plus b. So a plus b will be the 90
123.3.
plus 33.33, which is 120.33.
123.3.
Yeah, 120, sorry, 3.33. Yes, right. So that should be your correct answer. Yeah, okay. Range is like absurd. I guess it's 122 bit 128. Okay, but it shouldn't be that big range. But yeah, it is given in the problem. But in the exam, it will not be that much, right? The range in the exam will be like this, maybe 123 to 124 possibly, right? So the correct answer range is this. Okay, fine. Question number 5. Suppose that random variable x is uniformly distributed between 0 and 10. Find the value of probability that x plus 10 by x is greater than or equal to 7. Okay, how will you solve this problem then? This is like slightly tougher one, I guess. So x is given to me as what? A uniform random variable, and between 0 to 10, right? And I need to find out probability that x plus 10 by x greater than 7, greater than or equal to 7. How will you solve this problem?
So what I did is I solved this x plus 10 by x greater than or equal to 7.
Yeah, so you just
got-
basically created a equation, right?
Yes,
A
sir.
quadratic equation, possibly here. I think I
Yes,
can
sir.
just see that it's a quadratic equation. So how will you do that? So probability that, so x will be x square plus 10, right here. If
Yes,
this
sir.
x will go here and divided by x greater than or
Greater
equal to
than equal
7,
to 7.
again
So
I
x
can, in
square
the next step it will be x square plus 10 greater than or equal
greater
to
than equal to 7x.
7x, right? What else you can do now? You can just take that
Bring
7x
7x
to
to
left
left
side.
side.
Yeah. So it will be x square plus 7x
Minus 7x.
sorry, yeah, minus 7x plus 10 greater than or equal
Greater
to
than equal to 0.
0, right? So basically what we can do is, it's inequality sign. So generally what I think all of you know that x plus 10x equal to 7. We know how to solve this equality conditions, right? uh, Generally what we do is we just multiply this x square plus 10 equal to 7x, and then you'll bring that back here and equal to 0, right? Here we know how to solve the equality. Again, it will be same for inequalities also. Here we have this greater than or equal to. So we did the same thing. Now you can solve for this equation. So this is a quadratic equation. I can see the roots here itself, but okay, if you are not able to see that, how will you solve by basic,
X
Minus
square
a,
minus 5x.
minus by minus 2, sir.
yeah, maybe I'll just for those who don't know, right? So maybe there are few people who are watching. So a equal to here 1, b equal to minus 3, 7, and c equals to 10. So how will you find out the roots?
Minus b
Minus
plus
b
minus
plus
b
root
square
of,
minus 4ac.
yeah, root of b square
B
minus
square minus
4ac
4ac
divided by
by 2a.
2a. So I'll get the two roots of it, right? So minus b is plus 7 because b is minus 7. So minus of minus 7 is plus 7 plus minus root of b square is
49.
49. 4ac is 4 into
40.
1 into 10, which is
40.
40 divided by
2.
2 into 1, which is 2a. So here it is 7 plus minus
3.
3.
root of 9, right? Yeah, root of 9 plus 2, which is 7 plus minus 3 by 2. So 7 plus 3 by 2, which is 10 by 2, and another root is
4
7
by
minus 3, which is 4 by 2. So that is 5 and 2,
2.
right? So what does that mean here? Here that means probability that either x will take value as greater than or equal to 5 plus, right? Or, right, x will take the values as 2 or 5. Is that correct?
Yes, sir.
So what is probability that x is greater than 5? So first place, x is uniform, right? Uniform between 0 to 10. So what is the PDF of this? 1 by
1 by 10.
10. So when I say x is greater than 5, what does that mean? 5 into
5 by 10.
1 by 10, right? And greater than or equal to 2, what does that mean?
Less than 2, sir. Less than 2.
Less than or equal to, greater than?
Less than it should be.
Why it will be less than?
Or
Greater than, huh? Greater than, right? Because you have greater than equal to here, right? So when I say x is greater than equal to 5 and x is greater than equal to 2,
So you
right?
get x minus 5 into x minus 2, sir.
So x minus
So,
5, x minus
so
2.
either the product will be positive only when either the value is less than 2 or greater than 5.
No. I
The
think both.
product x minus 5 into x minus 2 will be positive only when the value is less than 2 or greater than 5.
2 square minus 4, 10.
If either x minus 5, x minus 2 both should be negative or both should be positive, only then it will be positive, sir.
Yeah, 5 should be positive and then 2 also should be positive. Huh?
So if it is greater than 5, then both will be positive,
Correct.
and if
Correct.
it is less than 2, then both will be
Yeah.
negative.
So here it will be less than or equal to 2, right? Yeah. So in that case, what is the value here? 2 into
1 by 10.
1 by 10. So finally it is 7 by
7 by
2. Just 0.7. Right, that's correct. So your answer should be
Is this the correct way to solve this, or is there any other way?
no. That's the correct way. That's the correct way.
Okay.
That's how to solve. Fine. Okay. Okay. What is the question
There
number?
is some transformed variable or something like that.
That is
There was a
next
lecture.
week. Next week. Next week. Week 12.
Okay.
Transformed random variables will learn it in the next week. So basically, what is transformed random variable? Okay, generally, okay, there is single random variable. We have already know how to transform it, but there are transformation of two random variables that we will see in the next week. But it will be similar. Like for example, you have that y equal to x square, right? So what does that mean by x now? X is root y, right?
Square root of y.
So that is what this is a transformation for single random variable. And what we are going to look into next week is transformation of two random variables. So let's say you have a joint density of x and y, and there is a function of these two random variable x and y in other values. Let's say u is equal to x plus y and v is equals to x minus y. Now what are the transformation here, right? So here it is u plus v by 2 and y is equals to v by 2. We will learn about that next week maybe. Okay, so when I talk about the two random variable transformation, I will talk about single values. Okay, this is okay,
So
right?
this is not a transformed variable, right?
This is
X
not.
plus
This is
10
not.
by x.
No, this is not a transform. This is like simple probability we are finding out, right? We are not transforming it into anything else.
No, I thought that x plus 10 by x is a transformed variable.
This one you can call it as like, yeah, but then you have to yeah, that this is okay, this also is fine. I can say that it is transformed, but okay, maybe I'll just talk about it. Maybe single random variables, right? I will take some examples of transform random variables for single also and then for both, right?
Okay.
Yeah, this is okay, right? How to solve this problem? That's fine, no
Yes,
issues.
sir.
Okay. Okay, what question number 6 you have to tell me? For a standard normal density curve, the value of standard deviation is 1. Is this correct statement?
Yes, sir. Yes, sir.
Okay, what is standard normal variable? How will you?
Mean is 0 and standard deviation is
Yeah.
1.
So normal, when x is called as a standard normal variable, when it is normal with mean equal to 0
0
and variance equal to
1.
1. So basically it is denoted by mu, and here it is sigma square. So this variance, so standard deviation will be square root of the variance. So square root of 1 is again 1. So that means option A is correct. What about the second statement? Normal distribution is also known as Gaussian. Is this correct?
Yes, sir.
We can call it as Gaussian distribution, but basically Gaussian is the standard normal, right? When the
Okay.
mean is 0 and this one variance is 1. Okay, what about the third option? In normal distribution, the highest value of its density occurs at mean. Is this correct?
Yes, sir. Yes, sir.
Right? Because if you know the curve, how it will look like this curve?
Bell shaped.
Yeah, bell shaped, right? And the highest density occurs at the mean, right? So this is the peak of the density, because on x-axis you have the values taken by the random variable, which is what? Minus infinity to plus infinity, right? For normal distribution. And what is the y-axis?
Probably the density.
Yeah. So density basically, right? Probability that x equal to x, or you can say that fx of x. So the highest density occurs at the mean. So option C is also correct. What about the fourth option? The width of the normal density curve increases as its standard deviation increases.
Yes, sir.
Correct? So, okay, I'll show you two graphs. You have to tell me whose standard deviation is highest. So one is like this. Sorry. like this. Another one is like this. So which is having the highest standard deviation, the
Black.
red graph or the black one?
Black.
Black one, right? So both of them are having the same mean here, right?
So mean is higher for the red one, right?
Mean is not higher, right? It's the same mean. The density is higher. The
Okay, okay,
probability
right,
of
right. Okay,
occurring
right,
it
right,
is
right.
right. It is
Yes,
higher,
sir.
but
Yes.
the mean is same. Okay, so
Okay.
the standard deviation for the red curve is less than the standard deviation for the. So what happens is when the standard deviation increases, the density is what happens? The probabilities are actually
Flattened, flattened.
yeah, flattened. So that means it will for other values also it will get distributed, right? So they are getting distributed to other values, so extreme values I can say, and hence the probability density at the mean it decreases. So you can see that the peak will decrease as my curve gets flattened out, right? Or the width gets higher, right? So in that case, the option 4, the width of the normal density curve increases. So width will increase as the standard deviation increases. And right, no?
Yes,
You
sir.
can
Yes, sir.
understand. So for the black curve, the standard deviation is higher. And if it is higher, what does that mean? The width of that curve is higher because this is the width, right? For the black curve, this is the width, and for the red one, this is the width. So width of that curve is lesser for the red curve, but the its standard deviation is also less. Okay, let's say x and y are the continuous random. What kind of problem is this? The question number 7, is this a joint distribution, right? The joint distribution of two random variables.
Yes, sir.
Right, so this is the joint distribution. So how to solve it now? Okay. All of you know about the single random variable. Now it is multiple random variable. So the joint density is given as what? Cxy. Cxy, and what is the range of x? It is between 0 to 2, and for y it is between 1 to 3. Okay, and it is 0 otherwise. And for this range, so in case of joint distribution, what we don't call it as range, we call it as what? Support, right? All of you have heard this term, support of the random variable.
Yes.
Two random variables. What do you mean by support? It is kind of a range, but generally what is the meaning, or what is the understanding of the support?
Where
The
the
density is not zero at that place.
So the probability exists, right? Or that so if I wanted to find out, so how to describe the support now here? Okay, so suppose here my x-axis is here and y-axis is here. So what is the range of x between
0 to 2.
0 to 2, and for y?
1 to 3.
So y is between 1 to 3, right? And the support can be shown by, let's say, this will be the support, right? Red portion is the support. Okay, where is the density lies? What do you think? Which axis? Or where are the probabilities? So this is a support, right? Is this support shows me the probability, or it just shows the area over which the probabilities are
Area.
non-zero, right? So it's a
Area.
area, and your probability is on the z-axis, right? Which is
Z-axis.
perpendicular to the screen here, right? So that means over this rectangular region where x goes from 0 to 2 and y goes from 1 to 3, the probabilities exist there, right?
Probability or the
Probabilities are
density,
non-zero.
sir?
Density.
Probability or the density?
Basically, this density, we can calculate the probability, and how to calculate the probabilities?
Integrate.
Integrate, or you can just multiply that area with the density. right? So for the simple shapes like the rectangle or the square or the circle, you can just find out the area and you can just multiply with the density, right? And what is the density over here, over this range? Cxy, right? So Cxy is the density, and this is this area. It shows the support. So in that support, what happens? Your probability density is non-zero, right? Or I can say greater than or equal to 0, right? And outside of this, what is the probability here or density here? Outside of this, it is 0, right? Fine. If you know and if you understand this part, then I think the other parts are very easy. So what is unknown here? C, right? Similar to probability mass function and probability density function, all the properties are applicable to here as well, right? So what does that mean? Now, if I integrate over the region, so from x goes from 0 to 2, and y goes from 1 to 3, fxy xy dy dx, right? So because y is like, this is the first, I can just use the dy first, right? You can use dx also first, that's not an issue. And that should be equal to how much?
1.
So over that support, if I integrate the joint density, it should be equal to 1. That is the meaning of it. So now I'll integrate from x equal to 0 to 2 and y equal to 1 to 3 c xy, right? Cxy is what? Joint density here. So dx into dy, and that should be equal to 1. So c anyway is a constant, so I can just take it out from x equal to 0 to 2. C is outside. What is the integration of xy? Here I have, so when I integrate with respect to y, in that case, what I have to do? I have to treat x as
Constant.
right? So treating x as constant, so that means I can take x out of the integration. So what is the integration of y into dy? Because
Y square by 2.
yeah. So first of all, I have to integrate this part, and in that case, I have to treat x as, this is constant, c is always also constant. So cx I'm just taking outside of the integration. So I'm just integrating y into dy. And what is the integration of y into dy?
Y square by 2.
Y square by 2. And what are the limits here? What is the
1
lower
to
limit?
3.
1,
to
and
3.
upper limit is 3 into dx, and that should be equal to 1. So if you see here, it is c into x. What is the upper limit now? If I replace it, it's y square
9
is
by 2.
9 by 2 minus
1 by 2. 1 by 2.
2, right? Into dx equal to 1, and integration x equal to 0 to 2. So cx, and here it is 8 by 2. 4. So now I need to integrate between 0 to 2, 4cx dx equal to 1. Now, if when I'm integrating with respect to x, what are the constants here?
4c.
4c. So I can take the constant outside of the integration. X goes from 0 to 2, x into dx equal to 1. You can see that. And what is the integration of x into dx?
X square by 2.
X square by 2. And what are the limits? 0 to 2, 4c equal to 1. And it is equal to 2 square. So that is 2 minus 0, right? 4c equal to 1. So basically it is 8c equal to 1. That gives me c as
1 by 8.
8. So now what is my joint density here? Fxy is
Xy by 8.
xy by 8. And what is the range, or what is the support when x goes from 0 to 2 and y goes
from 1 to 3.
Yes. And it is 0 otherwise. All of you understood this part? I think, yeah. Okay, nice. So I think we have done the, so what is the value of C, right? Question number 7. It is 1 by 8. And what is 1 by 8? 1 by 8 is
0.125. 125.
Right, so, and is it in the range?
Yes, sir.
Okay. Now we have to calculate probability that, okay, what is the meaning of this part? So probability that x is between 0 to 1 and y is between
1 to 2.
1 to 2. So what does that mean? Basically, you can just see that is it a what is this like? Is it's a joint probability we have to find out. Basically, it's an intersection, right? Or are x and y independent? How will you say that they are independent, x and y? When you have a joint density, how will you say that these two variables are independent?
The probability of x into probability of y should be equal to the joint.
So basically, joint density should be equal to the product of marginal. So this is called as a marginal density, right?
Yes, sir.
Is a marginal of x, and this is marginal density of y. Okay, we'll come to that later. First of all, we'll try to solve this probability. So we said that there was a support, right? So x was going between 0 to 2 and y was between 1 to 3. So we discovered, or we have found out, that this is the support, right? So this was the support here. So y was between 1 to 3 and this was the support. Now we need to find out the probability between, so when x takes values between 0 to 1. So which is the portion? 0 to 1 is this portion, right? And y is between 1 to 2. What does that mean? I have to find out the probability here, right? Can I directly find out the probability by using the area method?
No. Because the
So,
density is different at different places.
and when we use the area method, when the joint density is
Constant.
uniform, right? Yeah, constant, right? So when it is constant, or both the random variables are uniform, right? In that case, we can find it out. But for now, we cannot find it out. So what I have to do here?
Integrate again.
Yeah, right. So here I have to integrate from where to where?
X from 0 to 1 and y from 1 to 2.
Yeah. So integration from x goes from 0 to 1, y goes from 1 to 3, and 1 by 8.
1 to 2.
1 to 2.
1 to 2, sir.
1 to 2 and 1 by 8 into xy
XY.
and dy dx. So 1 by 8x, or maybe x by 8, I will take common. Here it will be y square by 2 from 1 to 2, and integration of x from 0 to 1 dx. Here it will become what? 3 by 2, right? So 2 square by 2 is basically 2 minus half. So 2 minus half is 3 by 2. So x by 8 into 3 by 2 dx goes from 0 to 1. This is 3 by 16 outside. Here it is x square by 2 between, I think it's 0 to 1. So here it is 3 by 16
into 1 by 2.
1 by 2. So that means 3 by
3 by 32.
32. And that should be my answer, right? So 3 by 32 is how much? I don't know. You can calculate. 3 by 32. Okay, maybe you can calculate it, right? So I think it should be correct. 3 by 32 is 0.09. So the answer is 0.09375. That is again correct. Okay, can you tell me now how to find out this probability that x takes values between 0 to 1 and y is greater than 2? Probability
It
that
is just one. Okay, now you have to again integrate.
we have to integrate, like, but what are the limits? So x will take from 0 to 1.
0 to 1
Y?
and 2 to 3.
Y equal to 2 to 3.
2 to
And we have to integrate 1 by 8 xy dy
Mhm.
dx. Will that be the same value or it will be different than the previous one?
different.
Different, right? Why? Because I think it's y square by 2 will goes from 2 to 3, right?
Yes, sir.
And x will be 0 to 1, that is same. And here it is dx. So the value will be 3
5
square
by
by
32.
9 by 2 minus 2. Is that correct? 5 by 2, right? So this is 5 by 2. So 5 by 16 basically into x
Into
dA
1 by 2, that is 5 by
0 to
32.
1. So 5 by 16 into x square by 2 from 0 to 1, which is 1 by 2.
5
So,
into 1 by 2.
yeah. And previously it was 3 by
3 by
32. Now here it is 5 by 32. And the answer to this is 5 by 32 is 0. 0.15625. This is the answer for question number 9. And I think that is again in the range of what about now? Okay, this is question number 10 is important. So it is x plus y is less than 3. To understand this, we have to again look at the support, right? So the support is, let's say, x and y. What is the support now?
0 to 2, 1 to 3.
2, 3. Right. The 1, 2, 3. Now we need to find out what now? This is question number 10. We need to find out probability that x plus y is less than 3.
Less than 3.
So how will you do that now? Okay, so just don't worry about the equality first of all. First of all, think about this as equation of line. So x plus y equal to 3. What is the equation of line here? Y equal to 3 minus
3 minus x.
6. So can you plot this over this region? So when
Yes,
x is
sir.
equals to 0, what is the value of y?
3.
3. Okay, so this is my 1 point. When x is equals to 1, what is the value of y?
2.
2, right? So I think it will be somewhere in the middle. And when x equals to 2, what is the value of y? 1. So can I say that this line will be like this? Sorry. This should be, this should go like this, I guess. Sorry.
It will intersect x axis
Yeah.
also at 3.
No,
It will
x-axis.
intersect.
Yeah, x-axis at 3, but the square where in the 2, right? So I think it goes into this like this, right?
Yes.
So this is the line. Is that correct?
Yes,
So
sir.
here, this will cut here and this will cut here. Okay. This is the equation of line. And what is the equation of this line? Y equal to 3 minus x. But here in equality, how it will look like? Y is less than 3 minus x, right? And this probability I need to find out. So which is the region where I have to look for? Is that
Lower.
low? So this is 1,
Below.
second, 1 and 2, which is the region. Y is
1.
less than 3 minus x. So yeah,
1.
y is less than 3 minus x is this region, right? So the first region. So what does that mean? I have to integrate within this region, region number 1, to get the required probability. And what is the second region? This represents probability that y greater than 3 minus x. So this is y probability that y is greater than 3 minus x, and this one region is probability is y is less than 3 minus x. Okay, so there are two methods, right? One is the horizontal strip method and another is vertical strip method. I can use any one of the methods. So I'll just use the horizontal strip method. This is the basic integration method, right? So what does that mean? I'll take a small strip here, right? And I'll integrate it from there to over this region, right? Okay. Now, what does that mean here? What is the equation of this line from this point? What is the equation of this line? Y equal to
0. Y equal to
Sorry, y equal to 0 or x equal to 0 here?
x equal to 0.
So here it is x equal to 0. And what is the equation of where it will cut here on this blue line? X equal to 3 minus y?
Yes, ma'am.
Or you can use, so if you are not comfortable with that, you can just use the vertical strip. So vertical strip, what will be the limit here? What is the equation of this line? Y equal to 1, right?
1. Y equal to 1.
And what about this part? Y equal to
3
3
minus
minus
x.
x. Okay. So you can solve both the ways. So maybe I can just use this limit. So maybe I'll use the vertical limit. So probability that y is less than 3 minus x is equal to basically, and when I use this vertical limit, okay, so red one. So here I am integrating from 1 to, so I'm integrating from y equal to 1 to y equal to 3 minus x by y into 8 dy dx. But at that time, what is the range of x now? So
0
from
to
where to
2.
where I'm going actually? I'm going over this region, right? So I'm using all the strips from 0 to 2,
2.
right? So x equal to 0 to 2. This is one, this is a vertical strip approach. What about the horizontal one? Sorry, I think I missed. Yeah. So if I use the horizontal one, what? How will I write that part? So here x will go from 0 to
0 to 3 minus y.
3 minus y, right? So x will go from 0 to 3 minus y, and y will go from where to where?
1 to 3.
1 to 3. Yes. So y equal to 1 to 3, and here xy by 8 dx dy. If you solve both the equations, right, or both the ways, you should get the same answer. I will show you both the ways, okay? So I'm just solving this first part. Where I'm integrating y first. So x by 8 is constant. X will go from 0 to 2. What is the integration of y? Y square by 2.
2.
And y will go from 1 to 3
3
minus x
minus x.
and dx here. So x by 8, because I'm integrating with respect to y, right? So x I'm treating as constant, and hence x by 8 is outside. Later part I have to integrate with respect to x, and x will go from 0 to 2. What is the okay, what are the, if I use the upper limit, this will be 3
3
minus x
minus x square
square
minus
by
1
2
minus
minus
1 by
1
1
by
by
2.
2.
Okay, dx. If I can expand it, what will be the expansion? So 3 minus x square is expansion is 9 minus 6x plus x square minus 1, and the common denominator as 2 into x by 8, and x will go from 0 to 2 dx. Again, this will inside what it will be, the x square minus 6x plus 8, right, divided by 2 into x by 8, and x will go from 0 to 2 and dx. Now this all function is in terms of x, right? So if you can see that this entire thing is the function of x, and now I can integrate with respect to x. Again, I can just expand it once more. It will become now x cube minus
Minus 6x square
6x square plus
plus 8x.
8x divided by 8 into 2, which is
16.
16. So I can just take out this 1 by 16 common and integrate with respect to dx, and x will go from
0
0
to
to
2.
2. So what is the integration now? X cube. What is the integration of x cube? X to the power
X 4
4,
by 8. X 4
4
by 4.
minus 6
6x square
into
by 3.
x cube by 3, right?
Yes.
And plus 8
X
x
square
square
by
by
2.
2, and the limits are 0 to
0 to 2.
2, and 1 by 16 was constant. It was taken outside, right? So already. Okay, so if I substitute the values, This 1 by 16 is outside. The upper limit is 2. So 2 to the power 4 divided by 4. How much it is? 16
4.
by 4. So that is 4 minus. So this is 2, right? And it is then
16.
16 plus is 4. 4 into 4. Again 16, right? And minus 0, basically. 16,
4
16.
by 16.
So 4 by 16 is 1 by 4.
4.
So that is 0.25.
25.
That is the probability that x plus y is less
Less
than
than 3.
3. And that I solved using the vertical strip. If I wanted to solve using the horizontal strip, how it will be. So both the answers should be same, right? So what are the limits here? X will go from 0 to 3 minus y. X will go from 0 to 3 minus y. And it is x
I
y
will
by,
go.
huh?
I will go from 1 to 3.
I will go from 1 to 3. This y is limits. Okay. So 1 by 8 common. And here when I am integrating with respect to x, in that case, I should treat y as
Constant.
constant. So that means y by 8 is here. And what is the integration of x dx now? X square by
2.
2. And what are the limits?
0 to 3 minus
3
y.
minus y. dy is already here and y will be equal to 1 to 3. So now everything will be in terms of y.
Y.
Right? So y by 8, and here it is 3 minus y whole square by 2 minus 0, right?
Yes, sir.
And y will go from 1 to 3. So y by 8 as it is, 3 minus y to the whole square is 9 minus 6y plus y square by 2 into dy, and y will be from 1 to 3. Now, if I expand it, so it will become 9y minus 6y square plus y cube by 16. Right? So this 1 by 16 I can take out as common and integrate from y equal to 1 to 3 dy. And what will be the integration?
9y square by 2.
Here it will be 9y square by 2 minus 6y cube by 3 plus y to the power 4 by 4.
4.
And the limits are from 1 to 3
to 3.
and it is 1 by 16. So if I put upper limit is 3. So 9 into 9, how much?
81 by 2.
By 2 minus 9 cube, so 3 cube by 3, which is again 9, right? 9 into
54.
6, it is
54.
54. And 3 to the power 4 is 81 by 4,
81 by 4.
correct? And minus 9 by 2, because y square is 1. Again, 6 into 3 is, basically it is 2. Minus 2 plus 1 by
1 by
4. So now 81 by 2 plus 81 by 4. It should be equal to how much? 81 and 81, right? So 81 into 2, how much it is?
243 by 4.
162 plus 81.
243 by 4.
243 by 4 minus 54. 1 by 16 is common to both. Minus here 18 plus 1, which is 19 by 4 minus 2. Right? So if you can just calculate here, it is 54 into 4. 54 into 4 is 216. So 243 minus 216 is 27 by 4, right? Minus 4 into 2 is 8, which is 11 by 4. 1 by 16 is outside. So 27 minus 11 is how much? 16. 16 by 4. So 16 get cancelled. I'll remain with 1 by 4, which is 0.25. You can just use anything like 16 by 4 into 1 by 16. The 16 will get cancelled, or 16 by 4 is 4. 4 by 16 again 1 by 4. You can use any calculation. So basically it is equal to 0.25, and you can see that if I use both the things, I'll get the same answer. I hope it is clear to you. I'm just getting too like little bit faster, but I don't have any other option. So okay, this okay?
Yes, sir.
Okay, what are the values? So again, how many questions are there? Oh, there are so
27.
many questions are there.
27.
Okay, fine. Let us we'll do it like little bit faster then. How to find? So I'll just show one question here. So fx of 1. What do you mean by fx of 1?
Marginal, the cumulative
No,
marginal.
it's not marginal. Yeah, CDF, right?
Cumulative.
So fx of 1. To find out fx of 1, I have to find out marginal density of x first. So
Yes,
fx
sir.
of x is what? How to find out the marginal density?
Integrate over y.
Integrate over y. So what is the range of y? Y equal
1
to
to 3.
1 to 3. And we have to integrate the joint
Fx
density, right? And what is the joint density?
xy by 8.
So it is xy by
8.
8. Integration from y equal to 1 to 3 dy.
dy.
So when I'm integrating with respect to y, that means x
X is
I have to
constant.
treat as constant. So x by 8 will be outside, and integration of y into dy is
Y square by 2.
square by 2. So
1 by
integrating over 1 to 3. So that means x by 8 as it is, y square is 9, right? So 9 by 2
minus 1
minus
by
1
2
by
is
2.
4.
That means 8 by 2, which is 4.
4.
So 4 means, and this will go
X by 2.
by 2. So you can just understand here is fx of x. The marginal density is, it will be always a
X by 2.
constant or a function of x, right? That is why it is called as the marginal density of x. So, and if I wanted to find the marginal density of y, what does that mean? It will always be
Integrate
a
over y.
constant. Yeah, integrate over x, range of
Yes,
x,
sir.
because that function, right? It should be the function of y. Now I know that it is x by 2. Now I have to find fx of x, fx of 1, right? Basically. So what does that mean? I have to find the probability that x is less than or equal to 1. This is the definition of CDF,
Cumulative.
right? Yeah. So probability that x is less than or equal to 1. And what is the range of x?
0 to 2.
So I have to integrate from 0 to 1
1.
here. And what I have to integrate?
X by 2.
X by 2 with respect to x. So 1 by 2 outside, it is x square by 2 from 0 to 1. So 1 by 2, x square by 2 is 1 by 2, which is
1 by
1 by 4, which is 0.25,
2.
right? Can you tell me what is the fx of 2?
That will be 1.
That should be equal to 1, right? Because then I'm integrating this marginal over the entire range of x. And when entire range, when I will integrate, that should be equal to 1, because that is a property of CDF. I hope all of you are with me, right?
Yes, sir.
Yeah. Okay. So now, what is the joint density of 1 comma 4? So okay, CDF of 1 comma 4. So here fxy of 1 comma 4. That means what?
X from 0 to 1 and y from 1 to 4. 1 to 4 or 1 to 3.
Yes, because what is the range of x?
1
X
to
is
3.
between 0 to 2 and y is
1
1
to
to
3.
3. So here, what I have asked here to find that fxy, the joint density or joint CDF? Joint CDF
CDF.
of x equal to 1. So that means x equal to 1 and y equal to 4. What does that mean? Probability that x is less than or equal to 1
1. Y
and
is less than equal to
y is
4.
less than or equal to 4. But y is less than or equal to 4 basically means y is less than or equal to
3.
3, right? And you can just understand, like it's just, I think it will be the same as that of 0.25, but let us see, right? Because y is less than 3 will give me 1, right? Okay, but let us see. So x will go from 0 to 1,
1.
and fx of x is how much? We have already calculated here. It is
X by 2.
x by 2.
2.
So it is x by 2 dx into y between 1 to 3, but I haven't find out fy of y, right? What is fy of y? Integration over the range of x, that is 0 to 2 fxy, which is xy by 8 dx. So basically y by 8 is constant, and it is x square by 2 from 0 to 2. So basically it is y by 4, right? 2 to the 4, 4, yeah, that's correct. Y by 4. So here it is y by 4 dy. So what is the
So they are
integral?
independent, right, sir?
We have to treat them independent, because you can just calculate here actually. What is the independence?
fxy equal to fx into fy.
So what is fx?
X by 2
By
and
2,
that is x
fy
by
is y by
y
4.
by 4, which
So
xy by 8.
xy by 8, and that is equal to
fxy.
the fxy, so joint density.
So
So
they are
when this will
independent.
happen, x and y, sorry, x and y are
Independent.
independent. Sorry. Uh, right. So basically, when I say the joint density is equal to the product of marginals, if this condition satisfies, in that case, x and y are independent. So here we are treating them independent, and when I say independent, then I can just use the product, right? I can use that product to solve, right? So here I can just independently integrate x and y here, right, over their respective ranges. So here x by 2 dx between over 0 to 1, what is it? X square by 4 between 0 to 1 plus 1 by 4. So y square by 2, right? So that is y square by 8. Y square by 8 from 1 to 3. And what is it? 1 by 4 plus 3 by, so 9 by 8 minus 1 by 8. Basically it is 8 by 8, that is 1. So 1 by 4 plus 1, plus or into, right?
Yes, into.
So 1 by 4 into 1 is 1 by 4, which
1 by
is
4,
0.25.
0.2.
So we have already know that, because we are integrating here. When I say probability that y is less than or equal to 3, what does that mean? Basically, it's we are multiplying the CDF by 1, right? So you should get the same answer. So I think the answer is correct, 0.25, right? That's okay.
Yes, sir.
Okay. So I think I'll skip some of the let's say 15. What is the you can just tell me the answers. So if x is exponential random variable with rate parameter lambda, which of the following statements are correct? Expectation of x is 1 by lambda. Is that correct?
Yes, sir.
Right. So in case of exponential random variable, so let us say, right. Okay. So when x is exponential lambda, in that case, expectation of x is 1 upon lambda. Variance of x is 1 upon lambda
Lambda.
square. And when x is Poisson with parameter lambda, in that case, what is the expectation of x? Lambda. And variance of x is lambda, right? You should know these two random variable, but exponential random variable is a continuous random variable, and Poisson is discrete. Okay. So option 1 is correct. Option 2, variance of x is 1 by lambda square.
Yes, correct.
Correct, right? Yeah.
Yes, sir.
What about provided that x is greater than x plus k given that x is greater than k? So that we have to solve. So probability that x is greater than small x plus small k given that x is greater than k. So this is the conditional density. So we know that probability that a given b, event a given b, what is it? Probability that a
A intersection
section
B
b divided by
or
probability of b,
B.
right? If I try to see this, like consider this as event a and this as event b. In that case, how will I write this probability? It will be probability that x greater than x plus k, and so basically intersection I just use, so when I say intersection, that means it's and, right, in probability terms, and we can just denote it by comma separated thing. X is greater than k and divided by b,
X
right?
is greater than K.
X is greater than k. So if you just see the number line, right? So when you have some x here, x plus some k, right? When I say that x will take values greater than x plus k, this is the portion, right? Right? Maybe you can just say that this is x plus k. Okay. So let us say this distance is k. So x to x plus k, and greater than x plus k is which one? The blue portion, right?
Yes, sir.
And what is the portion which I can say that x is greater than k? We are not able to show it on the line, right? We cannot
Yes, sir.
say that now what is x is greater than k. Let us see option D. So option D is what? Okay, that is okay. So let us say x is greater than k, and here when you say that x plus k, x is greater than x plus k, I can define here x plus k, which is the blue region. Is there any common between x greater than k and x greater than x plus k?
X greater than
Maybe
K.
I
X
can
greater
just
than K.
let us say k here. Here it is, let's say x plus k. In that case, can I show that? What is the common region here?
Greater than X plus K.
So when I say like this, probability that x is greater than x plus k and divided by probability that x is greater than k. Is greater than k, and here
I think this is a property of this distribution, right? That it is reflexive.
that is called as actually I forgot the name.
Reflective or
No, not reflective.
Theorem is there, sir.
Time. Huh?
Some theorem is there, no, sir?
Yeah. That is yeah. So I'm forgetting the name of it. But that is applicable to geometric distribution, I think, and that is applicable to
exponential.
yeah, exponential also. So one minute, timeless property or something like
Yes,
that.
timeless,
Yeah,
yes.
timeless, yeah.
Timeless, na?
Yes, sir.
One minute. Timeless or correct, right? Timeless property or
Timeless, yes, sir.
one minute. I'll just confirm once. Memoryless, sorry, not timeless.
Memoryless.
So memoryless property, right? So memoryless property is basically memoryless.
It works for geometric also, sir?
Yeah, geometric. Basically, it will work for geometric and this one. So basically, that property is like this: probability that x is greater than x plus k, given that x is greater than k. Okay, in that case, it is basically provided that x is greater than x. Okay, so this is a property. Why this is true is you can just imagine, right? So x is greater than x plus
To
k.
solve it, I think.
Huh?
We'll have to solve it using that equation for the.
Yeah, so provided that x is greater than k, right? You can solve it with the equation. It's easier. It's not like very tough, right? Because when I say that x is greater than x plus k and x is greater than k, but I think we can just show it through the number line. I'm not able to show you. I don't know. So when I say that x, right?
X is greater than x is like, and however much you increase the k, the probability will remain the same.
Yeah. No, you can just understand with the, like, you can think about it. So there is some number, right? So let's say x plus something. So when is x is greater than k, that is correct. So in that case, it will remain as like this. But maybe can you just check with yourself, or I need to solve it? Like maybe I can derive it also. Derivation
check.
is easier.
So we
You can check,
check.
right? Yeah, I
Yes.
think everywhere it is available. It's not like, but this is the correct property, right? So x is greater than x plus k and x is greater than k. So I think this option C is the correct one, right?
Yes, sir.
You can solve it. I think you can actually derive it like this. So what is the PDF of exponential distribution? It is basically, I think,
Lambda e raised to
lambda e
lambda
to the
e
power
raised.
minus lambda x, right?
Yes.
And then you can just add k, and then you can just find it out. I know that I can just solve it through, I can show you it on the number line, but okay, maybe I'll just after some time, maybe next session I'll just show you. Okay, maybe I can derive it also next session. But this is the option. Option C is correct. So A, B, C are the correct option. What about question number 16? So there are three
All the
events A, B, C, and probability of C is greater than 0. Which of the following are correct? A complement given C is 1 minus probability of A given C. Is that correct?
Yes, sir.
That's correct, right?
Yes, sir.
Complement actually, so basically A complement given C is like, we know that, right? So what are the property of complement? So let's say there is an event A, the probability of A complement is basically 1 minus probability of A, right? And
Yes,
this property holds true for the conditional probabilities as well. So let's say A complement given some event B, this is nothing but 1 minus probability of A given B, or vice versa, right? So I can say that A given B is same as that of 1 minus probability that A complement given B. Okay. So if I use that, then A complement given C is equal to 1 minus probability that A given C. So option A is correct. What about probability that phi given C? What is phi? Null
empty
event.
set.
Yeah, null
Empty set.
event or empty set, right? So null event. So what is the probability of null event?
0.
0. So probability of null event given that any other event A.
That is also 0.
0, right? So whatever is there, the probability of that null event, because in the numerator it will be what? So
Phi
probability.
intersection C.
Yeah. So probability
Phi
that null event C is basically probability of null event
intersection C.
intersection
Intersection C,
C
which is
divided by
0.
probability of C. So any event C, it will have what is the common element between a null event and any other event?
Null.
No element, right? So there is no element common between any event and null event. So that is basically no event. So basically it is null event. Probability of null event given that, so divided by probability of C. And probability of null event is
0.
0 divided by probability of C. So basically it is 0. So what is the probability that null event given C is 0? I hope all of you are, I am assuming that all of you are, remember all those things. That's why you have to go through, stats 1 and 2 if you forget anything, right? So I'm just doing it a little bit faster. Probability of A given C when probability of C is greater than 0.
Probability always less than 1, sir.
Less than 1. So that option C has to be true.
Correct.
So option 1 is correct, option B is correct, option C is correct. What about fourth option? A
That is
is a subset of B. That will be correct, right? Probability
Yes,
of
sir.
A given C is, so A, because B is a bigger event, right?
Yes.
So that means definitely the probability. So if you wanted to learn through Venn diagrams, so if you have this, let's say this is a sample space, there is event B and there is event A. So A is a subset of B, right? That means A is already contained into event B, right? And there is one event C, maybe it is both common in A and C, suppose. So probability that A given C is always less than or equal to probability that B given
B
C,
given C.
right? And if you can see that, that's a true, because A is already a subset of B, right? So definitely it will be, A is already contained into B, so this has to be true. Okay. Maybe 17th question you can just find it out. Okay, I'll just give you the hint of it. So A is the event that the first toss result in a head, tossing an unbiased coin 2 times. So A is the event that the first toss results in head. What are the elements of event A? So there are 2 coins which are tossed. What is the sample space? Head,
HH, HT, TH,
TT.
TT.
Event A is first toss is
First is head,
head. So what are the elements?
HH and HT.
HH and HT. Okay, what is B? B is the event that the second toss result in a tail. What are the elements in B?
HT, HT and
HT,
TT.
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 Only 2, right? What about option C? C is the event that on the both tosses the coin landed on the same side. What does that mean?
HH and TT.
HH and TT. Okay.
TT.
Now the question is A and C are independent. How to find out these events are independent?
Find their probabilities
Or
and
is
find the
or any other
A intersection B is equal to A into
so
probability of B.
probability of, okay, so you are saying that probability, okay, you can just find out anything. Okay, let us find out the probabilities. Okay, probability of A, what is the probability of A?
1 by 2.
So it's 1 by 2, right? Because there are 2 events or equal. If I take 2 equally likely events, then it's 2 by 4, which is 1 by 2. Probability of B,
1 by 2.
probability of C,
1
1
by
by
2.
2. So if I wanted to find that, and what is the joint probability of A and C?
1 by A and C, 1 by 4.
Because what is the common, when I say joint, what does that mean?
Common.
Probability that A intersection C, the common
HH.
so here HH
HH.
is the common. So the only element common here is, so if I just talk about the events here, if I talk about this event A intersection C, what is the element here? HH. So probability of A intersection C is what? 1
1
by
by 4.
4. What about A intersection B?
1 by 4.
What is the common element here?
HT.
A and B,
HT.
HT. Right, so HT is a common element. So here it is HT, and probability of A intersection B is how much?
1 by 4.
By 4. Okay, what about B and C? What is the intersection between B and C? Is there
TT.
TT? TT. So probability of B intersection C is
1 by 2. 1 by 4.
4, 1 by 4, right? So now if I wanted to see that whether A and C are independent, what I have to do? probability
A intersection
B should be equal to probability of
probability
A
of A
into
into probability
probability
of
of
C.
C. So probability of A intersection C is how much?
1
1
by
by
4.
4. What is product of A?
1 by
1
2
by
into 1 by
2.
2.
So 1 by 2 into 1 by 2. So which is 1 by 4. That means A and C are
Independent.
independent, right? Okay, what if I wanted to check whether the A and B are independent? So
Same,
A
sir.
intersection B is product of A into product of B. What is A intersection B?
1 by
1 by
4.
4. And that is equal to 1 by 2 into 1 by 2. So A and B are
Independent.
independent. What about A and B and C?
They are also independent.
They are also independent because 1 by 2 into 1 by 2 is 1 by 4 and product of B intersection C is 1 by 4. What does that mean is all are, so A, B, C are they, all three are independent?
No, because A intersection B intersection C is 0.
So yeah, so is there anything common between A, B and C, all three events?
No, no.
Nothing is common. So probability of A intersection B intersection C is, so basically there is no common element between A intersection B intersection C, that is null event, right? And probability of this A intersection B intersection C is basically probability of null event, which is equal to 0. So 0 is equals to probability of A into probability of B into probability of C. Basically it is 1 by 2 into 1 by 2 into 1 by 2, which is 1 by 8, right? So 0 is equal to 1 by 8?
No.
And hence A and A, B and C, they are not independent, right? But A and B are independent.
B and C is independent and A and C is independent.
A and C are independent, A and B are independent, B and C are independent, right? But A, B, C are not independent. So first three options are correct options, right?
So to find out whether A, B, and C are independent, the two pairwise should be also independent, and all the three should also be independent, right?
Yes, yes. So once there is like, if the A, B, C together are independent and the pairwise they are not independent, again A, B, and C are not independent, right?
Okay, pairwise
So
also they have to be independent.
yes, yes. Pairwise also they have to be independent. Here pairwise they are independent, but together they are not independent, right?
Independent.
Yeah.
Yes, sir.
Okay, fine. What about question 18? A1, A2, A3 to AN are the non-empty disjoint set. So they are not null, like they are not non-empty, right? That means they are not null. There is no any null event here. All are the disjoint set. What do you mean by disjoint?
Nothing common.
So there is no, so intersection between any of the events is
0.
0, right? That means empty set. And they are the subset of the sample space. That is okay. A set an plus 1 is also subset of S, then which of the following is true? So if A1, A2, A3 are AN are disjoint, so does that mean AN plus 1 is also disjoint?
No.
Think about it.
An plus 1 is also disjoint from
To
A
all
and
A1, A2, A3, let's say.
no, it may not be disjoint.
It may not be or it will be.
An plus 1 may have some common element between all the other sets, right, sir?
Yes, sir.
That is correct. Right. So because it is possible, because then it will become like that is the basis of Bayes rule, right?
Yes, sir.
Right. No. So because I think so, let us say this is the case. A1, A2 to A, like A1, A2, A3 up to AN. They are the disjoint set. This is a sample space. All are the events A1, A2. Now they are the subsets of the sample spaces, and the set AN plus 1 is also a subset of S. So AN plus 1 can be like this, right?
Yes,
Yes,
sir.
sir.
And if this is the case, then A1 intersection AN plus 1 exists, right? So A1
Yes.
and but the option says the intersection of all are disjoints.
Yes, they are disjoint.
That is possible. That is correct, right?
Yes, sir. It is always correct.
It should be always correct. Why? We can just see here. Suppose you have this an plus 1. Okay, an plus 1. What is a1 intersection an plus 1? This portion.
Yes, sir.
What is a2 intersection an plus 1? The green portion.
Second. Yes.
And what is a1 a3 intersection? This portion, right? So all these portions, are they, so this red, green, red and blue, are they disjoint from each other?
Yes, sir.
Yes. So when option A, just read the option A, what it is saying, A1 intersection AN plus 1, A2 intersection AN plus 1, A3 intersection AN plus 1, are they disjoint then?
Yes, sir.
Yes. So the case which we have taken here, this is the extreme case, right? Right. An plus 1 can be any event, but I have taken this extreme case. You can try to, you can try to contradict any this sentence. Suppose you have taken S, let's say A1, A2. So these are A1, A2 to AN, and AN plus 1 is here. So what are the intersection between A1 and AN plus 1?
Empty.
A1, so A1 intersection AN plus 1 is empty set. A2 intersection AN plus 1,
Empty set.
empty. So all are empty sets, and if all are empty sets, right, are they disjoint? So are this
Yes.
A1 intersection AN plus 1 and A2 intersection AN plus 1, is this
They
a
are
disjoint set?
disjoint.
Definitely they are
Yes.
disjoint. So if I take this two extreme case where AN plus 1 is, is a is common to all, A1 to AN, and if it is not, if it is disjoint from all, so in that case also, both the cases I can safely say that option A is the correct option. So any other
But
case
sir,
in between?
second case, sir, second case, they are disjoint, right, sir?
Definitely,
Yes,
definitely they are.
they are disjoint. Yes, they are disjoint.
So AN plus 1 is disjoint from any other, right? What does that mean? Definitely its intersection is disjoint to everyone, right?
Yes, sir.
Any other case, do you feel that it will contradict the first sentence, this sentence?
No, 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 no.
No, right? You can have any other, like let's say you have something like this. In that case also, this all these are disjoints.
Disjoint.
Okay, so is it correct? Option A is correct, safely correct. What about the second one? AN plus 1, AN are disjoint. Then A1 to AN minus 1 are disjoint to AN plus 1. Can we say that?
Not
Not
necessary.
necessary. Not necessary, right? Because we can show that very easily. So suppose this is a sample space, right? So this is A1, this is A2, this is A3. This is, let's say, AN minus 1, this is AN. Now, where should I put AN plus 1? So let us say this is
Except
AN.
AN, except AN, all the other, if
Yeah.
you include.
Can I
Yes.
say that it is blue is AN plus 1? So now AN plus 1 is disjoint from AN
Yes, sir.
because there is nothing common between AN and AN plus
AN
1.
plus 1.
That means AN and AN plus 1 are disjoint. But whether A1 and AN plus 1 disjoint?
No.
So here A1 intersection AN plus 1, it does exist, right?
Yes, sir.
This is AN intersection AN plus 1. So that means here A1 and AN plus 1 are not disjoint events, right? But AN and AN plus 1 are
Disjoint.
disjoint. So the second statement is wrong
Not.
or not true, right? But it, because it is not necessarily true, not all the cases, right? Some cases it might be, but mostly it is like not for all cases, right? Which case it will be true? Can you tell me where it will be true?
The second figure which you draw.
Yeah, this one, right? Where I have to remove this part now. If I just draw like this, A1, A2, is A3, then A4, or maybe I'll just say AN, and here it is AN plus 1, right? So now A1 and AN plus 1 is disjoint, A2 and AN plus 1 is disjoint, A3 and AN plus 1 disjoint, and AN and AN plus 1 disjoint. But that says option A is the correct option, option B is the wrong option. What about option C?
Correct, sir.
That's correct, right? Because A1, A2, A3, and AN are already given to me as
Disjoint.
disjoint event, and any null set definitely will be disjoint
Disjoint
to
from
me.
all.
Okay, what about option 4? Sample space. Wrong,
That
right?
is
Because sample space, all are A1, A2 to AN. They are the subsets of S. So they cannot be disjoint from S, right? What is common between event A1 and S,
A1.
right? You can see that. So if A1 is common for sample space and A1, A3 and sample space, yes, what is common? A3.
A3.
Like that, right? So that means they cannot be disjoint. When we can say that the two events are disjoint?
They have nothing in common.
Yeah. So intersection should be null event. Okay. Okay. So here, can you solve this one? So this is the PDF given to me, or I think it's PMF, right? PMF, because x takes value 0, 1, and 2, and probabilities are given to me. Or what is it? Triangular spinner have 3 outcomes and land on of the numbers. Okay, 0, 1, and 2, and so this is spun twice. The total number divided by x. Okay, so let us. This is actually what? This is a function of x, right?
So by looking only, you can say that the third
Yeah.
option is right
0,
because
1, 2. And what are the values taken by y?
0, 1, 2, 2,
4, right?
2, 2.
I have spun it twice, right? So twice is the
Okay, the second spin, the second spin will also give me 0, 1, 2 only.
so 0, 1, 2 and 0, 1, 2. What are the values then? Sum. It will be the sum, right? So let us say
Yes, sir.
x is 0, 1, 2, y is 0, 1, 2. Z is the sum of two numbers, x plus y. So Z will take values as 0,
0, 1,
1,
2,
2,
3,
3, and
4,
4.
4.
That's it. And what are the probabilities associated with x equal to 0, 1, 2? Is 0.7, 0.1, and 0.1.
2.
Sorry, 0.2 and 0.1. And here it is 0.7, 0.2, and 0.1. Same. So what are the probabilities? So 0 plus 0 is 0. That is possible only once, right? What is the probability of z equals to 0?
0.49. 0.7 into 0.7.
Right, it is 0.49, right? So it is probability basically probability of z equal to 0 is probability that x plus y equal to 0, and by the convolution theorem, that is probability that x equal to 0 and y equal to x minus 0, right?
Yes, sir.
So basically that is multiplication of probabilities, right? Okay, that is okay. So 0.49. What about 1?
0.28.
So 1 is possible
0.7
when
into
x equal to 0 and y equal to 1, and x equal to 1 and y equal to
y
0.
equal to 0.
So basically it is 0.7 into 0.2. It is 0.14
4
plus
into 2.
0.14. 2 times, right? So
0.28.
0.28. When it is 2 possible, once only. When x equals to 1 and y equal to 1.
2 and 0 also possible, sir.
Yeah, okay. 2 and 0 also possible. So 3 times, right? It is. Okay, so 3 possibilities are there when so z equals to 2 is possible when x equal to 0 and y equal to 2, plus probability that x equal to 1, y equal to 1, and probability that x equal to 2, y equal to
0.
so x equal to 0 into y equals to 2. So that is 0.07, right? 0.7 into 0.1. 0.07 plus 0.07, because when x equals to 2 and y equal to 0, what else? X equal to 1 and y equals to 1, which is 0.04.
0.04.
So total is 80,
0.18.
0.18. What about x equal to 3? Sorry, z equals to 3.
1
When
to
x
2, 1.
equals to 1 and y equals to 2, or x equals to 2 and y equal to 1. So 0.02 plus 0.02, which is
0.04.
0.04. 4 is possible when only 2, x equal to
0.01.
and y equals to 0 is 0.1. So if you can see that this is my PMF. And we have to check whether this is valid PMF or not. Valid PMF is when all the probabilities, the sum should be equal to 1 over the range of z. So the range of z is 0, 1, 2, 3, 4. And if I sum it, 0.49 plus 0.01 is 0.5, right? Plus 0.28 plus 0.18, how much it is? 0.46. 0.46 plus 0.04 is again 0.5. So 0.5 plus 0.5, that is equal to 1. So that is a valid PMF, and this should be the correct answer. So I think, okay.
Even without calculation, we can say, because you have not included 0. Other options are do not have 0.
So option C is basically correct. So it is 49 by 100 is basically 0.49. So you can just convert the probabilities into point, and you can see that that's the correct option. Okay. All of you, I'm just going a little bit faster, okay, but I think all of you know that already. Okay, question number 20. When throwing a fair die, what is the variance of the number of throws needed to get a 1? Variance of the number of throws needed to get
geometric distribution.
Yeah, it's a geometric distribution, right? So here, what is the success? Success is, so first place, it's a, so let us say throwing a fair die, right? So what is the probability mass function for that? Let us say, or I can say, what is the sample space? 1, 2, 3, 4,
3, 4, 5, 6.
6, and the probability associated with each of this number is
1 by 6.
Because this is so, and what is the, yeah, and what is the success here?
1 by 6.
Getting 1, right? So so my, let us say x is, either I will get 1, right, that is success, or I will not get 1. So I can just define it as 0. Probability of getting 1 is 1 by 6. And not getting 1 means what? Getting either 2 or 3 or 5 or 6, right? That is 5 by 6. So here the probability that x equals to small x is 1 by 6 and 5 by 6. I need to find out the variance, right? So what does that mean? I have to throw a die until I get a success, right? This is Bernoulli distribution, right? And geometric is what?
Till you get a success.
So either I'll get the success in the first toss, or maybe first roll, or the second roll, or like that, right? So basically, what is the distribution will look like?
One minus p raised to x t minus 1 into 1 into p.
So basically, if I have y as a geometric distribution, p is what?
Success.
And 1 minus p is the
variance.
So let us say there are a total of, like, I'll get in the nth trial, right? Or xth or yth trial. In that case, 1 minus p to the power y
So
minus
y
1. Or maybe I can just use n minus 1 into p,
into p.
right? So if I have x, then it should be x minus 1, right? What does that mean? That xth trial, I'll get the success. So what is the variance in that case now?
So your screen is not visible.
Not visible? Okay. Okay, I'm just getting it like little bit faster, but it's okay. Now is it visible? So, okay, this is my PMF, right? What is the variance of x? It is expectation of x square minus expectation of x
Expectation of x the whole square.
whole square, right? So that you have to find it out now. Okay, in this case, what is the expectation of x in the
1
geometry
by
system?
1 by p, sir. 1
1
by
by
p.
p, right? So expectation of x is 1 by p. And what is the variance now? I think
think
you
it is
know that formula is
1
already there, right? So
1 minus p by p square.
I'm not deriving it, right? You can just find it out.
1 minus p by p square. 1 minus p divided by p square.
1 minus p.
Divided by p square.
Okay. This is the final one, right? On what is the probability of success here? 1
1
by
by
6.
6.
By 6 square. So basically it is 5 by 6 divided by 1 by 36. Basically it is 5 by 6.
No, 30, sir. 30, 30.
30. Yeah, okay. So 6
36.
into 6 and 5 into 6, which is 30. Yeah. So the variance of x is here 30. Okay. So I'll derive that equation next session. Okay. This is possible for you to solve joint PMF.
Yes, sir.
Okay. I think mostly I've covered everything. This is fine. Maybe I'll just solve this one. And we can stop now today. We can, whatever remaining things are there, maybe we can just see the next session on Saturday. Okay, so this is the joint PMF given to me. Just a minute, I will just. Okay, my screen is visible, right?
Yes, sir.
Okay, so this is the question. So here, if you can just see. Okay, so this is what this is a PMF table. You can see here, right? It's a joint PMF table. Okay, joint PMF table of x and y. So what are the proper? What is this given to me? Fx of x here is a
Probability
marginal
of x.
marginal, right?
Marginal of x.
So it's a marginal of x. This fy of y is marginal of
Marginal
y.
y.
Okay, how to read it? Let's say fx of 1. What is it? Fx of 1 is a marginal density of x, and generally what is it? It's a summation over the range of
Y.
y. Summation of what? Joint probabilities, right? So
Yes.
this 0.05, what it denotes? It denotes probability that x equal to 1 and
And Y equal to
y
1.
equal to 1, which is denoted by fxy of 1 comma 1, that is equal to 0.05, right? That reads to be like that. So fx of 1 is what? For x equal for the fixed value of 1 over the range of y, right? I have to add all the probabilities, joint probabilities. So in this case, fx of 1 is equal to how much? 0.05 plus
Plus 0
0 plus
plus A1.
a1, that is equal to 0.15.
0.15.
So a1 is here, it's equal to 0.15 minus 0.05, that is 0.10.
1.
That is the value of a1, right? So now, can you just find it out so now a3 and a2 is unknown to me, right? What are the properties of this marginal densities? So fx of 1 plus fx of 2 plus fx of 3, that is should be equal to how much?
1.
1, right? The sum of all the marginal probabilities here, right, over the range of x, that should be equal to 1. So what is fx of 1? 0.15, right? Fx of 2 is
A2.
a2. Fx of 3 is
0.45.
45, and that is equal to 1. So a2 is equal to how much now? 1 minus
0.4.
0.6, which is 0.4.
4.
So a2 is 0.4. Now, if I know a2 is 0.4, what is the value of a3 then? So 0.4 equal to
0.1 plus 0.2 plus
0.1 plus 0.2 plus a3 is equal to 0.4. So a3 is equals to
0.1.
0.1, right? Okay, now uh, fy of 1 is equal to how much? 0.05
0.0
plus
plus
0.1 plus
plus
a4
A4 equal to
to
0.3.
0.3, right? So that is equal to 0.3. So what does that mean? A4 is
0.15.
0.3 is equal to 0.1 plus
0.05.
0.05 plus A4, and that A4 will be equal to 0.3 minus 0.15, which is 0.15, right? So now I have found out what A4. A4 is 0.15. Can I find out now A5?
Yes, sir.
So A5 is equals to 0.45 minus
0.35.
0.35, which is then
0.1.
0.1.
1.
And what is A6 now? A1 plus A3 plus
A5.
A5, or 0.3 plus 0.4 plus A6 equal to how much?
1.
1. So I can use that also, and that gives me A6 equal to 0.3.
0.3.
And you can just see that whether it's correct or not. So what is the value of A1? A1 was 0.10, right? A3 was 0.1. 0.1 plus 0.1, 0.2,
0.2.
right? And 0.
A5.
And A5 is how much?
0.1.
0.1. So total is
0.3.
0.3. So 0.1 plus 0.1 plus 0.1, that gives me A5, right? Or sorry, A6, that is 0.3. Or else, how can I find it out? So all the marginals, right? Fy of y, that should be the sum of all the marginals for y, that also should be equal to 1. That is 0.3 plus 0.4 plus A6 equal to 1. That gives me A6 as 1 minus 0.7, which is 0.3. That's correct, right? I hope
Yes, sir.
this is fine.
Yes.
In that case, now I have to find the value of, so I got all the values of now A1, A2, A3, A4, Y, A6, everything. Now I have to find Fy given that x equal to 3 of 1, right? So it is, I need to find out what I need to find out fy given x equal to 3 of 1, right? X equal to 3 of 1. What does that mean? I need to find probability that
X
y
equal to 3.
y equal to 1 given that x equal to 3. So basically it is conditional probability. And how we just find it out? Probability that y equal to 1 and
X equal
x
to
equal
3.
to 3 divided by probability that
X
x
equal
equal
to
to
3.
3. In other words, it is a joint density of 3 and 1, right? Fxy of 3 and 1 and divided by marginal density of x for 3. So fxy of 3 comma 1, what is it?
0.15.
So it is a5, right? So
Is
basically
sir, A5 thing,
a5 na x
A,
equal to 3,
no,
sorry, not a5, it is a1, a4, a4.
A4.
So what is the value of a4?
0.15.
0.15, right? So basically it is 0.15 divided by fy of, sorry, fx of 3, which is 0.45.
0.45.
So it is 0.45. Basically it is 1 by 3, which is 0.33. That should be the correct answer. I think that is the correct answer, right? Okay, so I think remaining things maybe I can just cover it on Saturday. We have like already out of time. So whatever remaining things are there, I'll try to cover it on Saturday, and we'll just look into week 12, which is I think which is the more important than week 11. All of you might know week 11. So if you have any doubts, right, regarding week 11, you just go through week 11, everything, every question. Any doubts will be there. We can cover it on Saturday.
Saturday 5 to 7, sir.
5 to 7, yeah. I'll just change the calendar also. It will reflect you in your calendar as well.
And the TA session will be from 7 to 9.
7 to 9.